Morning, everyone. Okay, so most of you have joined. Okay, so as I said, today we will be starting the revision of gravitation. Okay, now this chapter is closely related with electrostat. Okay, so I hope all of you have gone through the basic concepts of electrostat at least, right? You remember something about electrostat, right, everyone? Okay, yes, very good. Now, when we talk about the first topic of electrostat, just talk about the first topic of electrostat. Okay. Now, when we talk about the first topic of electrostat, it consists of the concepts like what is electrostatic force, right? What is field? What is potential? Yes or no, right? If I'm talking about the first topic of electrostat, it is electrostatic force or Coulomb's law, then superposition of forces, then electric field, concept of electric field, then concept of electric potential, right? That is your first topic. Okay. Now, the first topic that we studied in electrostat is almost same as the first topic of gravitation, which is again gravitational force, superposition principle, gravitational field, as well as gravitational potential. Now, my question is why these two fields are so similar? Tell me. Anyone have any idea? Tell me why these two forces, why these two fields are similar. Prashant, because they are non-contact. Because see, even your magnetic field is also non-contact force, na? Right? Magnetic field is also non-contact force, but still not the same, right? Yes? No. The main reason is both are conservative fields. Both electric field as well as gravitational field are conservative in nature. Yes or no? Tell me. Yes or no? Right? That is the main reason. Okay, and all the conservative fields will more or less behave in the same way, right? Right? Now, when you talk about, think about it. Okay, I'll just give you a basic idea. When you talk about potential energy, right? What's the definition of potential energy? Tell me. I'm just asking you the potential definition that we studied in class 9. I'm not asking you anything of class 12. Right? What's the basic definition of potential energy? Tell me. It is work done, right? It is work done. Yes or no? It is work done to bring an object from one point to another point. As simple as that, right? That is the basic definition. No, that's why I'm asking you the very basic definition. Yes, but whenever we talk about work done, it is due to some force. Yes or no? Due to some force, right? So if you talk about the actual definition of potential energy, right? If you remember the concepts of class 11th, right? Then the actual definition is work done, right? Work done by a conservative force, right? Work done by a conservative force to bring an object from one point to another point. Yes or no? Tell me, yes or no? Got it? So this is very simple concept, but this is right. The reason why I can say that electric field and gravitational field behave in the same way, right? Now I'll just cover both, okay, because they are analogous to each other. So I'll just cover the relationship between forces, right? How they are analogous to each other. Okay, got it? Right? Now, when we talk about Newton's law of gravitation, so Newton's law of gravitation, I hope all of us know what is Newton's law of gravitation. I need not to tell you what is Newton's law of gravitation. This is also inverse square law, which means the force is inversely proportional to distance square, right? Inversely proportional to distance square. Now, if I compare this with Coulomb's law, right? I can say that, okay, it is G Q1 Q2 by, sorry, K Q1 Q2 by R square, right? right? So I can say that both gravitational force as well as electrostatic force are of the same kind. The only thing is the mass is being replaced by charges. Mass is replaced by charges. Now, what is the only difference between these two? Tell me. What is the only difference between the gravitational force as well as electrostatic force? Tell me, everyone, what do you think? Nature of force, obviously, right? I'm talking about nature of forces. Yes, Manoj, very good. So gravitational force is always attractive. Gravitational force is always positive. This is always positive. It is always attractive because there is no concept of negative mass in our syllabus. Yes or no? Tell me, yes or no, right? So gravitational force is always attractive in nature, whereas when we talk about this electrostatic force, it is both positive and negative depending on the charges, right? Depending on the sign of the charges. If both are of the same size, then the force is positive, which means it is attractive in nature. But when we talk about opposite charges, right? When one is positive, one is negative, I can say that the product will be, sorry, it is not okay. The product will be negative, which means, tell me, in this case it is opposite, right? In this case it is opposite. So I can say that if charges are opposite, right, then force is attractive, right? And when the charges are, yes, when charges are same, the force is repulsive, right? That is one thing which is different from your gravitational force, right? But anyways, this is the scalar representation. This is the scalar formula for both gravitational force as well as electrostatic force. Now, we know that force is a vector quantity. Force is a vector quantity, and it will be along the direction, right? Or along the displacement between between the two objects. Yes or no? Tell me, yes or no, right? For example, if I'm having this mass 1 and mass 2, the distance between them, the distance between their centers is r, right? So I can say that M1 is getting attracted toward M2 and M2 is getting attracted toward M1, right? So if I want to find the force on this M1, okay, so it is in this direction, it is in this direction. So I can say that the direction of force, okay, the direction of force is, tell me, toward the line joining these two masses. Yes, yes. So I can say that it is F, magnitude of F, again magnitude of F into R12 cap, right? F vector is equal to yes or no? Tell me, yes or no, right? Or magnitude of F divided by magnitude of R into R vector 1 2 when we are talking about F12. Okay, now if you put this F as G m1 m2 by R square, it is your gravitational force. If you put this, it is your electrostatic force. So this is same for both. This is same for both. Okay, and as I say that, when you talk about displacement vector, so R12 vector, right, is actually negative of R21 vector. Yes or no? Tell me, yes or no? This is something that we have studied in vectors. So I can say that, okay, so F12 is equal to negative of F21, right? And this holds true for both gravitation as well as electrostat. Right, everyone? Tell me, right? So if we talk about the type of questions that can be asked, okay, so there's one type of question which is basic formula putting getting, that is very easy using the concept of vectors. Okay, and there's second type of question that can be asked. Okay, what are the second type of question? Tell me, tell me. This formula is applicable only for point mass, right? Or point charge. Yes or no? Tell me. When you talk about the formula, right? This formula is applicable for point mass and point charge, right? But when we have continuous mass distribution, a continuous charge distribution, I can say that we have to use integration. That we'll see. Okay, that we'll see when you talk about gravitational field or electric field. Okay, so these are some problems. So I hope all of you can solve this kind of problems, formula putting getting. Tell me. Yes. Okay. Now, this was the first topic. I hope everyone is clear on the first topic. What is gravitational force, right? What is its scalar form? What is its vector form? Then what is electrostatic force? What is its scalar form? What is its vector form? Now, in this, right, the second topic would be what? Tell me. Second topic would be superposition principle. Okay, superposition principle, right? But before that, I hope all of you can solve a problem like this. Tell me, yes or no? All of you can solve a problem like this. I hope remember this very famous problem, both in gravitation as well as in electrostat. You have to find the distance at which the force will be zero, right? Okay, so you just have to equate the forces. Yes? Okay, very good, everyone. Very good. Now, this is what I was talking about. Okay, this is what I was talking about, right? Neutral point, yes. Now, everyone, please go through this problem. Try to go through this problem. Okay, try to go through this problem. I hope you have done the same type of problem in electrostat, right? So what we have here is we have a thin rod of mass m and length L, which is bent in semicircle, right? It is bent in semicircle. So I can say that it is just like semicircle like this. Okay, it is like semicircle. So suppose this is your semicircle, right? Okay, so I can say that what is the gravitational force on point on a particle of mass m at O. So O is the center, O is the center, and I want to find this is m and this is half only. This is half only. Okay, this is half only, right? Okay, got it. So this is what I'm drawing, Manoj. This is the figure. Okay, so total mass of this is given as what? Tell me. Total mass of this is given as m. Mass of this is given as m. Okay, and length is given as mass m, length is given as L. You want to find the force at the center. Tell me. Now, what do you think? What will be the direction of force? Think about it. What will be the direction of force? Vertical. Very good, right? Vertical, because all the horizontal components will be cancelled, right? Yes. And since force is attractive, it will be in this direction. It will be in this direction. Yes or no? But I cannot use the formula. I cannot use the formula G m1 m2 by r square. Why? Because this is not your point charge. This is the continuous distribution of charges. Right, everyone? Okay. So what we have to do, we have to assume this dx element. We have to assume a dx element. Yes, very good. Right? Now this dx element, think about it. This dx element, right? This dx element is making d theta angle, and this is your dl. I'll just write as dl because total length is L now. So what is dm? Tell me, what is dm? I hope all of you know the concept of linear mass density. So lambda is equal to linear mass density m by L. Okay, now if the same problem is asked in electrostat, what would have been given? Instead of mass m, charge q would be given. In that case also, the linear charge density would be q by L, capital Q by L, right? Yes. Now what about dl? What about dl? dl is equal to, we know that theta is equal to L by R. So dl is equal to r d theta. Very good, r d theta. Yes, agree? Agree? Yes. So I can say that now df is equal to what? df is equal to g capital M, okay, capital M by L, which is this lambda, into dm, right? Got it? Sorry, into dl, sorry, dl, lambda into dl, because dm is equal to what? Dm is equal to lambda into dl, right? Into small m divided by r squared. Okay. Now, if this question is asked in terms of electrostat, right? So it would have been df is equal to k capital Q by L, capital Q by L, which is again lambda into dl into small q divided by r square. Think about it, yes or no? Think about it, yes or no? Right? Right? Now, depending on which component I want to find, I'll take, right, this angle. This is theta. Suppose this is theta, then that's why this is d theta, right? So this horizontal component, right, is your cos theta, and vertical component is sin theta. And we know that horizontal component will be cancelled. Horizontal component will be cancelled, right? Got it? Yes. So let's see. I hope all of you can see this. Okay. So since horizontal component will be cancelled, right? Cos theta will be 0. After integration, it will be 0. Okay. So I'll take the component in y, right? Which is this. Yes or no? Tell me yes or no. Yes. Now think about it. Suppose instead of pi, instead of this semicircle, you are given any random angle theta. Suppose this is given any random angle theta. So don't you think the integration limit will be 0 to theta? The integration limit will be 0 to theta. Yes, right? And formula would be what? Formula would be, tell me, formula would be in terms of theta. Yes, think about it. What would be the formula? Tell me, what about the formula? It will be G capital M small m by LR into cos theta. Cos theta. Yes or no? Tell me, yes or no? I'm just talking about the magnitude. Okay, I'm not talking about the direction. I'm just talking about the magnitude. Yes. Okay. Or in terms of what? Or in terms of, tell me. But there's a catch over here. If this is theta, think about it. If this angle is theta, then here it won't be cos theta, it will be sin theta. Yes or no? Don't mug up anything, right? Because here the theta is taken from horizontal, and I'm saying that this is theta, right? So this is theta. So the formula will change, right? The cos will become sin, the sin will become cos. Got it? Right? So you have to think that angle is taken from which side, either vertical or horizontal. Now, if you remember, then I can say that, what is this? What is this? It is in terms of lambda. It is G lambda M by R into sine theta. Yes or no? Tell me, yes or no? If I'm taking this angle, right? I'm taking this angle. Okay. In terms of electrostat, it will be what? K lambda into Q by R into sine theta. Makes sense? Tell me, makes sense? Got it? Yes or no? Think about it. Yes or no? Got it, everyone? Okay, very good. So this is the basic idea. So when we talk about force, okay, force first either point charges or continuous mass distribution. When we talk about continuous mass distribution, right, you have to take dm element, right, which is lambda or mass density any mass density. If it is line, it is lambda into dl. If it is area, then it is sigma into dA. If it is volume, then it is rho into dV, right? Okay, then yes, Harsha, because see, it will be in perpendicular bisector, na? Think about it, right? Think about it. Okay, I'm talking about perpendicular bisector, right? Then this component will cancel, na? Right? Always will cancel. Got it? Okay, Harsha? Okay. Now, after this, the next is superposition principle. I hope everyone knows superposition principle, right? Is there anyone who is having doubt in superposition principle? So can I say that it is the extension of Newton's second law? Tell me. It is extension of Newton's second law, right? Or I can say that the net sum of all the forces, okay, net sum of all the forces, right, is the sum of the forces, the sum of individual forces, right, added vectorly. Okay, added vectorly, right? Now, in boards, especially in 12th boards, lots of questions is asked on the superposition principle. Okay, now one such problems would be find the force at a point, okay, in the middle of equilateral triangle or one of the vertices of the square, right? Because of other three charges and all those things. So the problem in gravitation can also be asked in the same way. Yes, at the centroid or at any one vertices and all those things. Okay, got it, right? Right, everyone? So these are some points which we already like this. These are some points on gravitational force, right? Most of these points you already know. Okay, most of them you already know. That is a weak force. Okay, it is weak compared to electrostatic force. It is always attractive in nature, right? Total force is sum of all the forces. Means principle of superposition is valid, right? Whenever we have two bodies, there is always gravitational force between them, right? Got it? Yes. Okay. Now, I'm talking about these kind of problems. I hope all of you are aware how to solve these kind of problems. Yes or no? Tell me. Yes or no? Radhika, Anushri, Shreya, Chinmay. So these are the type 1 problems, right? Type 1 problems involve basic formula putting getting or using superposition principle. Now, there's one thing which I want to tell you, right? Whenever we use superposition principle, try to use the concept of, tell me, which concept? Either we can use either triangle of addition or resolution of vectors. My suggestion would be always use resolution of vectors. Okay, always use resolution of vectors because it is easy to add more than two forces. Yes or no? Tell me. Yes or no? Right? Break down each forces and its component, right? For example, when you talk about this, okay, when you talk about this, I'll just try to solve this one. I won't solve, I'll just give you the example. Suppose I want to find the force at this point, okay, at this point. Okay, so what I'll do is I'll start with making your axis, Always start like this. Okay, now when you talk about the forces, I can say that, okay, because of this mass C at point C, it will be upward direction because it is attractive. This is always attractive. So upward direction. This is force due to C. Okay, this is the force due to C. Right? Now, when you talk about B, now this is in this direction, and this point O is at the center. So I can say that force due to B will be in this direction like this. And force due to A will be in this direction like this. Okay. Now using basic geometry, I can find what is this angle. Yes or no? Right? And I can find the magnitude of this. So magnitude of this is suppose F1, magnitude of this is F2, magnitude of this is F3. So the best way is to divide your vectors here, forces, right? into its components, x component, y component, and just add them. Okay, that's the easiest way that reduce lots of errors. Okay, especially when we are dealing with more than two forces. Okay, now if in this case all the three forces are equal, so I can say that, okay, if I'm talking about this angle and this angle, these are 60 degrees, this is 60, this is 60 degree, so this is 60 degree, this is 60 degree, right? Yes. Okay, and since F2, F3, F1, magnitude of F1, F2, F3, magnitude of F1, F2, and F3 are equal, right? I can say that the vertical component of F2 and F3 will be equal to the vertical component or F1, and horizontal component will cancel each other. So net sum will be 0. Without solving, we can intuitively see, right? Okay, but if it is not equal, if F1, F2, F3 is not equal, then it will not be 0. Okay, then you have to break down into component and solve, right? So these are the first type of concepts using basic formula and superposition principle. Okay, now I hope all of you can solve this at the midpoint here. Okay, right? Okay. Now, when you talk about second type, type 2, okay, so type 1 we understood basic formula putting getting or using superposition principle. Okay, just think about the type of problems. The second type is whenever we have force, right, acceleration is associated with that, yes or no, right? So what I can do is I can involve your kinematics. I can use your equations of motion. Okay, I can use the concept of relative motion. I can use all the concepts that we have studied in kinematics. Yes, got it? So that is your type 2 problems. Okay, so type 2 problems is totally intuitive based formulas. Okay, we just have three formulas. There's nothing else in kinematics. It's just how you understand the problem, how you solve it. Sorry, I was disconnected. Yeah, we have used kinematics in almost every chapter where force is involved, right? Be it your electrostat or magnetic forces. Yes or no? I hope all of you remember, right? Okay, so this is type 2 problems, right? Type 2 problems. So when you talk about this, okay, most of you might have found this problem as difficult, but it's actually very easy. How? I hope all of you remember this formula. V is equal to U plus AT, right? Or V square is equal to U square plus 2AS. Now this is applicable for relative velocity also, right? If I'm talking about only one frame, this is applicable for relative velocity also, right? So I can use the concept of relative velocity. Yes or no? Tell me yes or no. Right? Okay. Yes, A must be constant. That's why instead of using this in this case, since A was not constant, I will use the basic formula, right? Basic definition of A, which is minus dy dt, which is minus dy dr into V. Okay, got it? Tell me, got it? So this was a good problem, okay, because it included the concept of kinematics, and only the acceleration component is taken from your gravitational concept. Got it? So this is your level 2 kind of problem where you have to use multiple concepts. Got it, everyone? Now, if you think about it, right, there is no concept which is very high level. Yes or no? We have basic definition of acceleration, which is dv by dt or dv by dr into dr by dt, right? Which is dv by dr into v. And then you have a concept of acceleration, relative acceleration due to forces. Okay. and I just equated those two and calculated the velocity. Now, since acceleration is not constant over here, I cannot use v square is equal to u square plus 2s. That's why I will use the basic idea. I hope all of you remember how we derived v square is equal to u square plus 2s. Don't you think that we derived in the same way? Tell me, we derived in the same way, yes or no? Right? So it's not something that we have not studied. Okay. Now, these are the problems that can be asked. These are the problems. Okay. What will happen to the force when this cavity is removed? So the best example, right? Sorry, it is also as an electrostat where from a charge, right? Spherical charge, a charge or cavity is made. So what do we used to do? Tell me, what do we used to do in these type of problems? We try to calculate the force due to hole sphere and we subtract the force due to this cavity. Yes or no? That's what we used to do. Yes, agree. Okay, so these are the type 3 problems. Okay, now this is again type 1 problem. Type 1 problem, okay, where you are asked to find the force due to continuous mass distribution. Okay, continuous mass distribution. So you can remember this as a formula also. You can remember this as a formula also. Okay, but I hope all of you can derive this. It's quite simple. It is same as the one we derived. Okay, hemispherical one. Don't you think this is same? The only thing that will change over is radius r. Okay, sorry, not radius, displacement. My bad. Okay, displacement. So you can remember this as a formula. Yes, tell me. Yes, everyone got this. Tell me, everyone got this. Now instead of mass, I can say that it is a charge of q with length l. What would be the change? So I can say that the change will be simple. Same formula. Instead of g, put k. Instead of capital M, capital small m, put q divided by, instead of d, same d and l plus d. This will be the force due to, tell me, this will be the force due to a rod having charge q. Yes or no? Tell me, yes or no? That's why the topic 1 of both electrostatic and gravitation are same, exactly same. You just have to replace g with k, q1, q2 with m1, m2. Right? The only thing that you have to notice is charges. But when you talk about scalar values, right, you don't have to worry about that also. And the charges, right, the direction of force or field, you can just think about the charge, na, right? If it is positive, negative, you can just see the direction. Okay. Okay. I hope all of you clear. The next is, so this was about force. This was about force. Now, when you talk about field, think about it. When you talk about field, okay. So what is the basic definition of field? I'm not talking about gravitational field. What is the basic definition of field? Think about it. Think about it. It is the area, it is the space, right, around which or around an object up to which its effect is observed. Yes or no? This is the intuitive definition, right? Now, when you talk about equation wise, I can say that field, okay, field is, right, ratio of force per unit object. Now, when you talk about gravitation, it is per unit mass. When you talk about electricity, it is per unit charge, right? Yes. Similar to acceleration. Yes. Got it? Tell me. Got it? Now, we know that this mass and charge both are scalar quantity. So I can say that if F is a vector, E is also a vector, the direction of F and E are same. The direction of F and E will be same in case of gravitational force. In case of gravitational force. But when we talk about electrostatic force, the charge of Q matters. The charge can be positive and negative. So depending on that, the direction of E will either be in same direction with F or in opposite direction, because Q can also be positive as well as negative. Right, everyone? Right? Okay. Now, this is very important concept. This is very important concept because when we talk about the distribution of charges, okay, so instead of finding the forces due to different configuration, we try to find the field and we will find the force simultaneously. Okay, now think about it, right? We studied what is gravitational field. Gravitational field. Gravitational field is basically same as acceleration due to gravity, which is weight by mass or which is force per unit mass. Okay. Now, when we talk about the type 1 problem is formula putting getting. Yes or no? Type 1 is formula putting getting. No doubt in that place. Okay, no doubt in that concept. Now, when we talk about type 2 problems, okay, type 2 problems involve the concept of superposition. So the concept of superposition can also be used in the same way as we used in force, right? There's no difference at all, no difference at all, right? The only thing that we have to know is when we talk about force, it is due to two different objects, yes or no? Force is due to two different objects. But when we talk about field, it is due to only one object, okay, one mass, right? As simple as that, as simple as that. Okay. Now, when you talk about different configuration, so for point mass, we know that it is gm by r square. Okay, gm by r square. E is equal to gm by r square. Direction same, r cap. When you talk about electrostatic force, it is kq by r square, same r cap. No changes in the formula also. Okay. Now, when we talk about the different configuration, the easiest one is sphere. Yes or no? The easiest one to remember to solve is sphere. Okay. Now, when we talk about sphere, we have two different type of sphere. Okay. We have either hollow sphere or solid sphere. Okay, either hollow sphere or solid sphere. Now, when we talk about hollow sphere, okay, when we talk about hollow sphere, it means there's nothing inside the sphere. Okay, there's no mass or charge. Okay, now if there's no mass or charge, right? So I can say that I'm either taking a point which is inside the sphere or outside the sphere. Okay, now if I'm taking yes, if I'm taking a point inside the sphere, okay, inside the sphere, right, in solid sphere and outside the sphere, so I can say that if I'm taking outside, then no issue. It is considered as a point charge, yes or no? If the point is taken outside the sphere, then it is considered as point charge. The formula is gm by r square, right? And for charge, suppose this is charge, it is kq by r square. Same formula again. That's why I'm taking the analogous, right? Both topics. Now, if r is equal to r, again, same formula. So kq by r square. Now, when it is inside, then we have a issues, right? Then we have an issue. Okay, then we have issues. Now, it is solid sphere made up of charge, right? Or made up of mass. So I can say that if I'm talking about this point, I can say that the field will be due to the mass inside this red circle. Yes or no? Right? The field will be due to this mass or charge inside this red circle. So I want to find the field. So we know that, okay, dE is equal to what? Tell me, dE is equal to what? G, tell me, gm by, tell me, r square. But this m is not the mass of whole sphere. This m is mass of this smaller circle, and we know that mass of small circle is, right, rho density into volume of small circle. Yes or no? So small m is, this rho is capital M by Now again, 4 by 3, 4 by 3, pi will get cancelled. This is small r square and this is capital R, sorry, small r cube and capital R cube. So if we put it over here, I can say that E, I'll just write E, is equal to G capital M by R cube. Now, small r square, small r cube. So we'll get R. Easy? Tell me, easy? No integration involved here, no integration required. You can use integration, but it's not required. Okay, right? Got it? Yes or no? Now, when you talk about electric field, so it is KQ, again, GM KQ by capital R's cube into R, as simple as that, same formula, same formula. Okay, same graph also, same graph also. Okay, got it everyone, got it? Now, when you talk about electric charges, we have one more setup, which is conducting sphere. Conducting sphere. So conducting sphere behave in the same way as hollow sphere. Yes or no? Tell me. Conducting sphere behave same as hollow sphere. Right? Same formula, everything is same. Okay? Right? Okay. Now this is about sphere. Now, when you talk about other configuration, right? When you talk about other configuration, okay, yes, Faraday's cage. Now think about it. This is a problem. Okay, this is a problem. You have to find G at the center of this hollow sphere. Tell me, can you do that? Tell me, can you do that? Think about it. Can you do that? These type of question can be asked in your boards, by the way, right? Don't underestimate the level of boards. Okay, boards have asked the questions like derive the formula of electric field due to finite line charge or ring. Okay, so we will start with very basic. Yes. Now, the only question that we should ask is, what is the elemental area? What is the elemental area or elemental portion that we have to take over here? So it is quite evident that the elemental portion that we will take is ring. Okay, is ring, right? Okay. Now, we will come back to this problem. Okay, first we'll try to find. I hope all of you know how to find the electric field due to ring. Yes or no? Tell me. I hope all of you know how to find electric field due to ring. Yes. So I'm not trying to derive all the formulas over here. Okay, right? I just give you the idea, because when we talk about gravitation, then gravitation, okay, right? You don't have to derive the formula, you just have to remember the basic formula. So the different, wait, I'll just show you the different configurations. Okay. Just give me a minute. Yes. So the different configuration that we have to remember, we have to know is this: point, ring, disk, hollow sphere, solid sphere, right? Got it? And then again, your finite line charge, finite line charge. Line charge. Okay, then we talk about electric field. Okay, got it? Now I hope all of you already derived these formulas. Tell me. I hope, yes, yes, rod only. Rod only. In case of gravitation, it will be rod only. So I hope all of you remember the formula. The formula was K lambda by D, right? K lambda by D sine alpha plus sine beta. Yes or no? Right? This is what? This is E. This was EX. EX. Right? Depending on what is alpha, what is beta. I'm considering that this is alpha, this is beta. Okay. Now, if I want to find EY was what? Sine beta, sorry, cos beta minus cos alpha. I hope all of you remember the formula. Okay. Now, if I want to find the formula of Ex due to rod, what do you think? What would the change in this formula? It would be G lambda by D into same sine alpha plus sine beta. Don't you think? Tell me, don't you think that this will be the same formula? Yes, right? Where lambda is mass density, linear mass density. Okay. So if you observe the formula of field, right? This is due to point, this is due to ring. Now, I'll just write electric field also. So just replace, I'm not worried about charge. I'm not worried about this negative positive, okay? Because the definition says that it is bringing this point is brought from infinity to 1 point or 1 point to infinity. That's why the sign will be different depending on the definition. Okay, because we know that we cannot find the potential, we can only find the change, right? So it will be what? I'm talking about gravitational field, because if we know gravitational field, we can integrate and find gravitational potential. Okay, I hope this is clear for you guys. Okay, so it is kq by r square and kq by r. Due to ring, it is kqx by, again same, r square r to power 3 by 2. This capital R square plus x square, I'm writing a small r to power 3 by 2. Potential, again kq by small r, again small r, okay, which is r square plus x square. Now, disk, instead of g, just use k. Simple as that. Instead of g, just use k. Just use k. Instead of g, just use k. Hollow sphere, instead of g, just use kq. Right? Got it? Tell me. Tell me, everyone. Neat students, you have to remember the formula only. Okay. Right? Derivation. We will do. Do I need to do the derivation? I hope all of you already studied the derivation part. That I will do for revision purpose in boards class. Neat students, if you want, we can have the derivation in second class today. Okay. Tell me, guys. So I hope all of you can derive these formulas, yes or no. If not, right, then let me know. Okay, I'll help you to derive. I'll take a, I'll derive everything in the second class of NEET and I'll record the video and send it to you guys, okay, the J students, okay, right? Now, think about it. What are the type of problems that can be asked? Okay, what are the type of problems that can be asked? Simple formula putting getting problems, yes or no? Simple formula putting getting problems, right? So mostly when you talk about these concepts, mostly simple formula putting getting, right? Or using work energy conservation, these two type of problems is asked, as simple as that. Okay, got it? Both in electrostat as well as in gravitation. Okay. Now till this, both the topics are equal. Till this, both the topics are equal. Now, but when we talk about gravitation, okay, there's one more concept, right, which is variation of gravity. Okay, variation of gravity and definition of gravity. So we know that what is gravity? Gravity is nothing but your gravitational field or acceleration due to gravity. Yes or no? Tell me. Yes or no? Right? And since it is F by R, sorry, F by M, since it is F by M, G is equal to F by M, G will vary whenever there is variation in force. Makes sense? G will vary whenever there's variation in force. Okay, and we know that force can vary if we vary your position as well as mass. Make sense? Tell me, make sense? Yes or no? Yes. So I can say that there is actually, yes, there are actually two ways, not two ways, there's actually three ways in which I can vary the gravity. Okay. First, by varying the height. Okay, so I can say that if I'm considering, yeah, if I'm considering the height above the Earth's surface, if I'm considering the height above the Earth's surface, okay, right, then G will change. If I'm considering the height below the Earth's surface, then G will change. Or if I consider the rotation of Earth, right, then G will change because of net force or net change in acceleration. Make sense? Tell me, make sense? Okay. Now we will see them each one by one, but before that, the other type of question that can be asked is the percentage error one, right? Okay, so we know that the force formula is given by G m1 m2 by r square, and G is equal to F by N. So G is Gm by r square. So there's one type of problem that can be asked, what is the change, right? What is the change in gravity when mass is changed to this point and this is changed to this point, right? So you can just use the concept of, tell me, error and measurements. Yes or no? Tell me, yes or no? I hope all of you know this concept already. Okay, right. Now, when you talk about variation in G, so I told you the first variation is when an object is taken h height above the Earth's surface. Okay, very simple. The only thing that you have to change is this distance. Okay, now when you talk about this, F is equal to G m1 m2 by r plus h. Take out r, take out r. So I can say that it is written as this G capital M small m by capital R squared bracket 1 divided by 1 plus h by r whole square. Make sense? Make sense? And G m1 m2 by r square, if you divide by small m, I'll get G dash is equal to G m by r square, which is nothing but G naught into this, which is 1 plus h by r to whole minus 2. And if you know 1 plus x to the power n is equal to 1 plus nx if x is very, very small than 1. Yes or no? Tell me, yes or no? Neat students, if you don't know this, right? This is the concept, this is a property for binomial theorem. Okay, Prashant, got it? Tell me, got it? Okay, so can I say that? Can I say that here x is what? Here x is h by r, h by r, and this is very, very less than 1, which means h should be very, very less than r, right? Okay, so h should not be comparable to r, then this whole term 1 plus h by r to the power minus 2 can be written as 1 minus 2h by r. Okay, got it? Right, as simple as that. If h is comparable to r, then you have to use this formula only. This formula only, na? As simple as that. You don't have to use the approximation. Okay, got it? Suppose an example, in a problem, you are given that h is equal to r by 2 or r by 3 or r by 10, right? You cannot ignore h, this h in that case. You cannot say that it is very less. Okay. Yes. Okay. Very good. Now, this is about height. Now, when we talk about depth, think about it. Think about it. Okay. Same thing will happen. No? Same thing will happen. F G M M by R minus H whole square. Okay. Yes. No. 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 Right. This is one misconception, because when you talk about this mass, right, this will change. I cannot use this formula. I cannot use this formula. Which formula I have to use? I have to use this formula. GMM by R cube into X. Yes or no? Tell me. F is equal to, or E is equal to G capital M by R cube into X. Makes sense? Tell me, Manoj, makes sense? And what is R? What is R? Sorry, what is this X? X is equal to the height from the, tell me, this center, which is capital R minus H, because this H is this height, okay? Now, just put it, after putting it, right, we will get something like this. So this formula is not obtained by approximation. This is not approximation, okay? Got it? So you can use this formula in all the cases, but you cannot use this formula in all the cases, right? Make sense? Tell me, make sense? Yes, very good. Now, what will happen? What will happen if we talk about rotation? Think about it. Okay, what will happen when we talk about rotation? Now, if we talk about rotation, think about it. Okay, this is one problem that I guess all of you can solve. This, I'll share this PDF. Don't worry, I'll share this, not PDF, PPT. Okay, I'll share this PPT, but try to solve this. Okay, this one also. Now, next is variation of G due to Earth rotation. Think about it. I told you G will vary wherever there's change in force, net force, right? And when we talk about this F, what is the direction of F, guys? Tell me, what is the direction of F due to gravity? Tell me, what's the direction? Tell me. Yes, toward the center, right? Toward the center. Now, can I say that? Can I say that if I'm talking about any object moving in a circle, then there will be a centripetal force. Tell me, there will be a centripetal force and centrifugal force, right? Got it? And this force will have a component in this direction, yes or no? Suppose this is theta, this will be having a component in this n direction, yes or no? Yes. So can I say that? Can I say that? Okay, F net is equal to Fg, Fg. Okay, think about it. Fg minus, because it is in, okay. All of you can see the screen now. Tell me, all of you can see the screen? Yes. Okay. So I was saying that F net, yes, right? So when I talk about F net, so mg, usually mg is equal to n, but now it is m omega squared r cos phi plus n. Yes or no? Tell me, yes or no? Right? And this is your total F net, है ना? I told you F net is equal to what? Mg Fg minus m omega squared. Now, this is small r. If you replace small r with capital R, so I can say that the small r is equal to capital R cos theta. Yes or no? Depending on what theta you're taking, right? Depending on what theta you're taking, right? Got it? Yes. Okay. So it is m omega squared capital R cos square theta. As simple as that. Okay? Makes sense? Right? Right, everyone? Now, this is which component? This is your vertical component. When you talk about horizontal component, then it will be this. Okay, but anyways, we need not to worry about this. Okay, don't worry about this. Okay, right? So usually we take this component only. So G effective will be G minus omega square cos square theta, omega square R cos square theta or phi. Okay, now that's why I can say that when my object is at equator, think about it. When my object is at equator, right? Is at equator, then this theta is 0, right? Yes or no? Tell me, yes or no? Right? And if theta is 0, I can say that this term cos square theta is 1, which means g dash is minimum. G dash is minimum, right? But when we are at pole, this is maximum because this term cos theta is 0. Theta is 90, so this is 0. So that's why we say that whenever we buy something from equator and go to pole, right? It weighs heavier. Yes or no? It doesn't actually change in the mass, right? In amount, but the gravity changes. Got it, everyone? Got it? Yes? Okay. Very good. Very good. Right? The next concept is work done or gravitational potential energy. So I hope all of you remember. Harsha told you, no? Right? One cos theta is because of the component C. That's what I said. When we talk about m omega squared, small r cos phi. Now, this small r is also capital R cos theta, na? Hai ki nahi? Tell me. Got it, Harsha? Got it, everyone? Right? This small r is this radius, and capital is this radius. So, if you convert the small r in terms of capital R, it is r cos theta. Got it? Okay. Now, I hope all of you remember the basic definition of potential, right? Basic definition of potential energy. So, since chapter 5 or 6, we have been studying about this potential energy. The definition is same. There's no change in potential energy. It is, tell me, it is the amount of work done, right? Amount of work done by shifting an object from one point to another point, right? Under the action of conservative force. Yes or no? Tell me. I'm just talking about potential energy. I'm not talking about gravitational potential energy, right? Okay, now if that conservative force is your gravitational force, then it is your gravitational potential energy. And if that conservative force is your electric force, right, electrostatic force, then it is your, tell me, then it is your electrostatic potential energy. Yes or no? Tell me, yes or no? It is minus K Q1 Q2 by R, as simple as that. Or plus K1 Q2 by R, depending on you are taking from which point to which point. Okay, and actually it's not U, it is delta U, delta U. Okay, got it, right? Okay, now there's a concept, right? Now when we talk about the velocity, okay, right? If we want to throw something, right, so that it reached up to a certain height h. I hope that this problem will be very easy using the concept of conservation of energy. Yes or no? Tell me, yes or no? Right? Yes, we just start with conservation of energy at this point, right? Potential energy is G m1 m2 by Re minus. We use minus because we consider the potential energy from one point to infinity, right? So final is 0. Initial is something. That's why it is negative. Got it? Got it, everyone? Okay. So this is the initial energy and this is the final energy, right? So if you just equate and solve, you will get V square is equal to this. V square is equal to this. Now this is very important. Why this is very important? Tell me why this is very important. Because it will be used to find, okay, the velocity in some other orbit, right? Okay, and all those concepts. Yes, escape velocity as well as satellite velocity. Now, as I told you, this is the basic derivation. We cannot find the potential energy. We can always find the change. So the actual formula is this, right? G M1 by Rm minus 1 by Rb, depending on what is the position of A and B. Okay, it is negative of work done, right? Okay. Now, we know that when you talk about potential energy or potential, it is a scalar quantity. It is scalar quantity. That's why when you talk about the potential energy of a system, okay, right? For example, here we are talking about the potential energy due to three masses or three charges, right? It is the sum of potential energy between all the pairs, means 1, 2, 2, 3, 3, 1, right? 3, 2. Okay, all the three pairs, and they are just added algebraically. That's it. Okay, now if you talk about charges, it will be k q1 q2 by r plus k q1 q3 by r, k q2 q3 by r, as simple as that, right? Okay, anyone have any issue in potential energy? Tell me, anyone have any issue in potential energy? Tell me, guys, be it gravitational or electrostatics. Tell me. See, whenever I'll tell you what is the doubt for students. Okay, the doubt usually comes in the direction. Okay, right? So what I would suggest, try to think intuitively. Try to think intuitively. For example, suppose we are asked to find. Suppose this is a mass and this is a point which is distance r. R. Now this point A and this is point B. Now suppose you take something from here to here, right? Here to here. What do you think? What do you think? Work is done against the force, or tell me, work is done against the force? It is gravitational force. Suppose it is gravitational force, right? Against the field or toward the field? Tell me. Work is done against the field or toward the field? Against, right? So work done will be negative. Yes or no? Work done will be negative. So what will be change in potential energy? What will be change in potential energy? Okay, got it? Yes, got it? Any issues in this? Tell me, any issue in this? Yes, Harsha, because when you talk about electrostat, right? Okay, it depends on charge. It depends on charge. For example, if it is positive charge, then the electric field is in this direction. Now, yes or no? Tell me, yes or no? Right? Now, in this case, if it is moving from A to B, the work done is positive. It's not negative, right? That's why we have change in sign. That's why I'm asking you to just think about the basic, right? Intuitively think about the basic, because magnitude wise it's no difference. The only difference would be sign. Think about like this now. But if this charge is negative, right, then obviously in case of electrostat also that will be negative sign. Yes or no? Tell me, yes or no? Because in this case, right, the field will be in this direction. So instead of mugging up, just talk about work done, think about work done, right? And the change potential energy will be negative of that. Okay? Make sense? Tell me, make sense? Everyone? Clear? Okay, very good. Okay. Now the next concept is potential. I hope all of you are aware of this term, right? Because it is very important in, tell me, very important in what? Electrostat. Very important in electrostat. Super important, right? When you talk about potential, it is also something related with potential energy, okay, or work done. Now, when you talk about this potential, okay, so I can say that it is defined as, okay, work done per unit mass or work done per unit charge. Yes or no, right? Tell me. So I can say that it is actually the work done to bring a unit mass from one point to other point. Okay, unit mass, right? Yes. So potential is, now this is W, work done. This is W. Okay, by mass or work done per unit charge in case of electrostat. Now, don't you think that this work done is actually, I'm just talking about magnitude wise direction. I'm not worried about direction. Direction we can think of, right? Okay, I'm just worried about the values. Okay, so this work done is basically what? Potential energy only, right? Right? Yes or no? Or F into dr, F dot dr. Think about it, F dot dr, right? So can I say that, okay, V is equal to F by M dot dr, or dV is equal to. Now, if you integrate it, we will get what? V is equal to integration of, what is F by M? Tell me, what is F by M? What is F by M? And here it is F by Q. What is F by Q? F by M. Don't you think it is E? E dot dr? Yes or no? Tell me, yes or no? So potential can be said that it is integration of E dot dr, but we know that work done is negative, right? This is when you talk about this, okay, dot. Now, depending on the direction of displacement and force, right, we can have negative sign over here. Yes or no? Tell me, yes or no? Right? Okay, got it? Tell me, got it? Now, due to point charge, we know that due to point charge, V is equal to what? V is equal to Gm by R. Okay, because E, right, Gm by R makes sense. Tell me, makes sense. But in terms of potential for gravitation, okay, obviously we'll have negative. Okay, anyone have any issue? Tell me, anyone have any issue in this? Anyone have any issue in this? Tell me. No. Now, as we calculated the field for different configuration, we have to calculate the potential for different configuration also. Okay, and everything is easy except for the potential due to sphere inside the sphere. So this is one formula that you have to remember. Okay, because every other formula is easy. It is easy to integrate. Okay, but not this one. Now, when you talk about potential due to sphere inside the sphere, okay, it is this. Why it is this? Tell me, why it is this? Tell me why it is this. Anyone? Tell me, anyone? Because when you talk about potential, okay, we know that this potential will be due to both outer mass as well as inner mass. Yes or no? Tell me, yes or no? Now think about it, right? I'll try to give you basic idea. Okay, I'll try to give you basic idea. Now think about it. Suppose you talk about this point, okay, inside point, this inside point. Now, this is infinity, right? Suppose you are bringing a mass from this point till this point, okay? And this point is suppose A. So what is the potential difference? Tell me, what is the potential difference? Think about it. What is the potential difference? What is change in potential? Don't you think that this should be VA? Yes or no? That should be VA. Guys, can you hear me? I'm not getting response. Can you hear me? Guys, can you hear me? Okay, you are messaging to co-host. Okay. Sorry guys, you are messaging to co-host. Okay. Host kya? Okay, so because of okay, yeah, sorry. My host got changed because it's my on my phone now. Host on my phone. Okay. Anyways, I was just checking my laptop for the messages. Okay. So see, think about it logically, right? Think about it. So I can say that till this point, the potential is VA. Yes or no? And you want to find the potential at this point. Now, don't you think that when you talk about this object from this point to this point, we will have some work done. Okay, that is VA. That is calculated using basic formula. But when object is coming from point A to point A to point B, there'll be different work done. Tell me, there'll be different work done. Yes. So this is point B. Okay. Yes. And I can say that the total work done is from 0 to or infinity to A plus A to B. Yes or no? Tell me, yes or no? Got it? Tell me, got it? Right, everyone? So whenever we write the formula for potential, think about it. How this is very easy, how this is not difficult, right? You might be asked to solve it. So can I say that, okay, potential formula, it's very easy, sir. What you are saying, it is easy. It is E dot dr or EDR, right? I'm considering that this is 0 degree, right? Now it is infinity to point B, but we know integration. Everyone know integration over here, right? E is not same throughout the point from infinity to B. So can I break it down? V is equal to minus, I'll keep minus outside. It will be what? It will be infinity to A EDR plus integration of A to B EDR. Make sense? Tell me, make sense now? Yes or no? Yes or no? Make sense? Because infinity to A, electric field is different, right? Electric field, I'll write E1 and E2. So E1 is equal to what? E1 is equal to simple G M by R square, right? R square. Okay, right? But when you talk about E2, it is what? G mr by r cube. So formula of E1, E2 is not different. Sorry, not same. That's why, right? Otherwise, the derivation is not difficult. I hope all of you understood the derivation. Tell me. I hope now you understood the derivation. Now it's easy, right? Got it? Prashant, Himashri, Spurti? Okay, very good, right? Very good. Or you just remember this formula. Okay, if you ever forget, then you can easily derive now. Okay, very good. Yes, very good. Now this is applicable for both. As I said, the concept, right? The concept is applicable to both electrostat as well as gravitation. Okay. Now this is another topic. Okay, both gravitation and electrostat, which is self energy of uniform sphere. Okay, so self energy will be because of its own mass, its own gravity. Yes or no? Tell me, yes or no? Right? Okay. Now, when you talk about its own mass, which is this, and mass of an elemental area. So what I assume is I want to find the force or the energy, okay, the energy of this elemental mass, okay, due to this whole sphere, right? So total M is this V into rho density, and this elemental mass is 4 pi r squared into rho. Then if you calculate, right, you will get this 3 by 5 gm square by r. Got it, everyone? Tell me, got it? Yes or no? Right? In terms of potential, in terms of electrostat, it will be 3 by 5 kq square by r. So this is the formula of self energy of a uniform sphere, right? You just remember this, okay? You don't have to derive everything, just remember this. But I hope all of you understood how it is derived. It's not that difficult, right? Got it? Samik, Vishnu, Manoj, Dilip, Uday, Abhishek, Abhin. Okay, very good. Okay, so this is something that we already discussed. Okay, this is something we already discussed. So this is the part one. This is the part one, okay, of electrostat as well as gravitation. Okay, so this is the part one, right? So I hope part one is clear. Okay, I hope part one is clear. Tell me, right? Now, in part one, there's some more concept, right? Some more concept, additional concept when you talk about gravitation. Okay, it's not in electrostatics, gravitation. Okay, now the concept is of escape velocity, okay, or the velocity of a satellite in a given orbit. Okay, now when you talk about it, when you talk about the escape velocity, okay, these are some problems of HC which you have to solve. I've written over here, right? These are some problems which are good. Okay, okay, yes. So this is part two. Now, when we talk about part two, okay, now I hope all of you are aware that when we talk about the motion of satellites and planets, it's not circular, right? It's not circular. Yes or no? Yes or no? But all the calculation that we do, okay, is according to circular one. Okay, so do not get confused on that, right? Whenever we talk about escape velocity or whatever we calculate, we consider the circular one because again, the mathematics involved with elliptical path will be difficult. Okay, right? Got it? Now, there are two concepts that you should use. There are two concepts that you should use. I'll give you some good problems. I'll give you some good problems. I'll show you some good problems. Okay, whenever you talk about the problems of this concept, you have to use conservation of momentum and conservation of energy. As simple as that. Okay, yes or no? Tell me, yes or no? Because when you talk about planet and satellite, right, both are one system. Both are one system with no external force. Yes, right? So can I say that? Can I say that the momentum, the angular momentum, because it's revolution, right? The angular momentum around the center of the planet will be conserved, right? And the energy will be conserved anyways. Okay, right? I'll show you how that concept is used. Okay, I'll just give you an idea that we have to know these concepts. Okay, now, okay. Now, when we talk about velocity, I hope all of you remember the velocity, right? How to find the velocity of any object within a circle, right? Yes, which is just equated with your centrifugal force, you get the velocity. Okay, so suppose if we talk about any object which is revolving around a mass m at radius r, then this velocity is root gr. Yes or no? Tell me, yes or no? Right? So I can say that, okay, this is the velocity of the satellite, okay, of the satellite when it is revolving around the Earth, right? At a distance r from the center. Makes sense? Makes sense? Yes or no? Okay, easy? Easy everyone? And angular velocity is v naught by r. So it is gm by r cube. It is quite easy. Now, remember, v naught is equal to root gr is the velocity. This r is the distance. It's not the radius, to be very frank, right? Where r is equal to capital R plus h. See, कट गया ना, कट गया ना. And see, it is g na, gm by r square, gm by r square, gm by r square into r. Okay, यहाँ पे ये m कट गया, यहाँ पे ये गलती से लिखा हुआ है, ठीक है? समझ में आ प्रशांत? प्रशांत समझ में आ रहा है? ये गलती से लिखा हुआ है because mm कट गया ना, mm will cancel, right? Okay. Okay. So root gr is the velocity of a satellite which is revolving around the planet at distance r from the center. Okay. Now, when you talk about escape velocity, so for escape velocity, we will use what? Tell me. For escape velocity, we will use what? Which concept we will use? Tell me. Anyone? Yes, conservation of energy, right? Okay. Conservation of energy. Very good. Now, if you see this, right, what is this? Right, I'll just give you an idea. I hope all of you remember, not 2 pi root L by G. Yes or no? Tell me, yes or no? ये क्या है? यही है ना? देखो, 2 pi root of R by small g, because R cube is R square into R and GM by R square is G. ठीक है? तो सब फॉर्मूला एक ही है, सारा फॉर्मूला एक है. Okay. Now think about it. Think about it. Whenever we talk about satellite, okay, it is moving with some kinetic energy, right? This is what we studied. And don't you think this is same as the atomic structure? This is same as the concept in atomic structure? Yes or no? Tell me. Yes or no? Right? That kinetic energy is half of potential energy. Kinetic energy is half of potential energy. Okay. Right? So total energy is also negative of kinetic energy, right? Same concept, same concept. Okay. Now escape velocity. So as I said, what is the definition of escape velocity? First of all, you should know what is the definition of escape velocity. Tell me. Tell me, everyone, what is the definition of escape velocity? Tell me, if you know what is the definition of escape velocity, then it is easy to find. Basically, it is the velocity, the minimum velocity to escape, yes, very good, to escape Earth gravitational field, right? Earth gravitational force, yes or no? Yes or no? Minimum velocity. So can I say that? Can I say that? Okay, it is a distance. It is a distance where Earth is not affecting your object. Okay, if Earth is not affecting your object, then I can say that energy at that point is zero. Potential energy at that point is zero. Yes or no? Yes or no? Right? And since escape velocity is the minimum velocity, the kinetic energy should also be zero. Right? So I will use what? I'll use conservation of energy. I'll use the conservation of energy. So suppose I'm on Earth and I'm throwing something. I'm on Earth and I'm throwing something. So we know that at Earth, okay, on Earth, if I'm throwing this with velocity v, it will have kinetic energy which is half mv square, and it will have potential energy which is gm m2 I by r. But I'm saying that finally it is escaping the Earth gravity, so net energy will be zero. If you calculate, you will get what? Root 2 gm by r, which is root 2 gr. Yes or no? Tell me yes or no. So this is your escape velocity. Root 2 gi is your escape velocity. Make sense? Right? So what are the factors on which the escape velocity will depend? Tell me, what are the factors on which escape velocity will depend? Yes, mass of the planet, right? Radius of the planet, right? Anna, got it? Mass and radius both. Means whatever will affect G, it will be affected, right? Escape velocity will be affected. So many questions is asked, okay, where they'll give you the variation, ratio of masses, ratio of radius, and they'll find the ratio of escape velocity. Many questions will be there in previous year. Okay? Okay, very good. Right? Got it? Tell me, got it? So as I said, it depends on mass and radius and position where it is projected. Got it? So these are the different form of your escape velocity. Okay, in terms of G, in terms of mass and capital G, in terms of density, and as we know, it is not at all depending on the angle, right? The angle or at which the object is thrown. Okay, so these are some problems. Okay, these are some problems. There are some good problems. Okay, please try to solve. Okay. Now the only thing which is left is Kepler's law. Okay, the only thing which is left is Kepler's law, but that is just theory. Thus, just theory. The only thing that you have to remember is T square is equal to R by T square is directly equal to R cube, right? Okay, and equal time have equal area swept. Got it, right? Got it. Now, when you talk about the one type of problem that I was saying, wait, I'll just show you the type of problem that I was showing. Wait, guys. Problem. Okay, I guess I'm not finding those problems. Okay, so what I'll do, yes, I'll just send the problems in group. Okay, Harsha, right? I'm not finding those problems now. I'll just send that in the group. Okay, you please go through that. Where the concept of, yes, angular momentum and energy is used. Okay, so I hope all of you understood the basic concept of gravitation. Yes or no? Tell me. Yes. Okay, so all of you, I'll upload the PDF. Okay, I'll upload the PDF as well as